Why exactly do we have leap day? And how did mankind figure out that we needed it in the first place? On my quest to find answers, I traveled to the UW Planetarium. While there, I chatted with my astronomer friend who also wrote a book called The Last Stargazers, Emily Levesque. So here we are in the beautiful planetarium staring at the night sky because it turns out leap year does have to do with celestial events. So why do we have leap year? Because, I mean, it almost seems pointless to add an extra day to give people, I don't know, special anniversaries and birthdays. But there's importance behind this.
Yeah, so the leap year comes from how we define a year. We're used to thinking of a year as 365 days long. And a year is supposed to be how long it takes the Earth to go around the sun once.
Okay.
And 365 days is almost right. It takes the Earth just a little bit longer to make that trip. It takes us 365 and 1/4 days to make the loop. So we need to add a little extra time to the year to kind of make up for that difference. And
okay.
It would be a little weird to add a quarter year every year. Nobody wants to make plans like, I'll see you next Thursday and a half.
Right, that's a good point.
The easiest way to do it is to just add one day every 4 years.
So if we didn't add the extra day, would it impact all aspects of our lives?
Yeah, it would make a surprising difference. If we didn't add that extra day every 4 years, if we just made every year 365 days long, we'd start every year about 6 hours earlier than the one before. And 6 hours doesn't sound like a lot, but we've been doing this leap year thing for over 2,000 years. If we hadn't done that, if we just stuck with the 365 days the whole time, our calendars would right now be telling us that we're somewhere in late July. And we'd already be halfway through the year 2025. So all the seasons would shift, all our holidays, all our sort of senses of what temperature it's supposed to be in what month would all have changed over time because we didn't add that extra day.
Incredible. And that would affect how we plan things, how we do farming, all the things.
Everything, yep.
All right, so I understand, like you mentioned, it was about 2,000 plus years ago, like early era, 46 BC. So how did people in like the ancient olden days realize they needed to do this? How were they keeping time?
It's a great question. So that 46 BC that you mentioned is when Julius Caesar officially announced, all right, we're adding a day every February, every 4 years. But for centuries before that, people all over the world had been sort of refining and perfecting what they called a year. And some of it came from what I just described. People would make up a calendar and then they would notice that seasons were drifting, that farming timing was getting a little different, and they would tweak or adjust to make the year length match more what they were seeing around them. So some cultures add a day, some add a month, some do a mix of these things, and a lot of it had just been from noticing how that time drifted. We eventually got pretty good at measuring how long a year was, and it was by looking at how the sun actually moves in the sky. If you were to go out and mark on a chart of the sky exactly where the sun sits at noon every day for a whole year, it would trace out this nice little figure 8. And that shape comes from the Earth's orbit around the sun and how the sun appears to move to us. So the sun will go back to exactly the same spot in that figure 8 once exactly a year has passed. And that's how we got to that 365 and about a quarter.
That's pretty fascinating. Oh my gosh. All right, so Earth's been around for like, what, 4.65-ish billion years? Is it ever gonna go faster or slower? Are we gonna ever have to adjust the amount of days? Like instead of one leap day, we might have 2?
So we've done a few adjustments to the leap year approach already, and right now we're doing pretty well. We lose a little over a day about every 8,000 years right now, so we've got some time. But there are other little quirks here. Something we've been sort of ignoring while we talk is I've said, well, we change how long a year is and how long we think of a year, and I say, oh, it's 365 and a quarter days. But we haven't talked about how long a day is. And a day is how long it takes the Earth to complete one spin, to rotate once. And that will change a little bit. This can depend on everything from the sort of tug of war we have with the moon because of gravity. It could depend on things like melting glaciers or big earthquakes. And the Earth's rotation will change just a teensy bit. People might remember that we had a leap second about 8 years ago at the end of 2016. And that leap second got added occasionally to make up for these little wiggles in the Earth's rotation, but that's a lot more chaotic and unpredictable, so the leap seconds aren't that nice regular every 4 years tick like we have with leap years.
That's fascinating. I mean, I could really do with an extra hour in the day. I mean, I think everyone could. That's really fascinating, but I don't want the big volcanoes, earthquakes, or, planet-altering effects.
No.
So let's just stick with what we got. All this talk about how in ancient times they really had to pay attention to these things makes me think of, how did people handle these celestial events back in the day? Like with an eclipse, let's say. I mean, they must have thought the world was ending.
Eclipses are really surprising if you don't know what's coming. And what's amazing is that because of observations like what we've just talked about, getting really good at understanding how the Earth goes around the sun or how the moon goes around the Earth, we can now predict total solar eclipses very accurately. So we don't suddenly have the sky changing and the sun seemingly going dark.
Yeah.
We can plan ahead and plan great trips to enjoy an eclipse.
There's a coming up an eclipse, right, in Ohio?
There's an eclipse coming up on April 8th. And here in Seattle, we'll be able to see a little bit of it. On April 8th at about 11:30, if you go out with safe eclipse goggles or other viewing equipment, you'll see it looks like a little bite will have been taken out of the sun. It's about 30% covered. But if you go out to, like you said, Ohio or Southwest Texas or northern New York, you'll be able to see a total solar eclipse, which is just amazing. It's absolutely worth the trip.